I just started the recording. So just a reminder, and I will take homework questions to start, but your homework number 6, excuse me, is due tonight by 11:59, so no late submissions. So just make sure you get that in. And I will post by Thursday, before the start of class on Thursday, your final homework assignment, which will be due the 17th. Okay, yeah, let's take a look. So let's start class. Let's take a look at any homework questions. Okay. So Pamela, you want me to look at question number 4 and some of question number 5? Okay, no problem. All right, so even before I begin, everybody take out your graphing calculator. Just have that handy. We're going to use it a bunch today. Pretty much we're going to use our graphing calculator to do to do every problem going forward. So just have it handy. Okay. Okay, so homework help. So let's look at problem number 4 on the homework.
Cereal, yeah.
All right. So I muted everybody, but you can unmute yourself if you wanted to ask a question. So question number 4 goes like this. A recent Pew Research poll of 500 adults, okay, were asked about their online versus in-store clothes shopping, okay? One finding was that 32% of respondents never clothes shop online, which is probably very different than what it is now post-COVID. But anyways, this problem I made pre-COVID. So construct and interpret a 95% confidence interval for the proportion of all US adults who never clothes shop online. Okay, so what information are they giving you? They're giving you the sample size is 500, right? All right, and what else are they giving you just looking at this?
P hat.
Yeah, they're giving you P hat. Yeah, they're saying P hat is equal to 0.32 or 32%. Okay, what they're not giving you is X, okay, which we're going to need, okay, because we're going to need to plug that into our graphing calculator. Can anybody tell me how I can find X? Well, what is the formula for P hat? It's what over what? It's X over N. You're close. And so, yep. So look at this. I know what P hat is, 0.32. I don't know what X is, but I know what 500 is. I know what N is. It's 500. So I'm just going to solve for X here. So to solve for X, I'm just going to multiply both sides by 500. They cancel here. And X is equal to, let's do 500 times 0.32, and you get 160. Yep. Daniela had it in there in the chat there. Okay, so that's 160. All right, now we can use our calculator to find the 95% confidence interval. So if you grab your trusty calculator here, you're going to press the stat button. You're going to scroll over to tests. And then does anybody remember for a confidence interval for a proportion what I scroll down and find? Yep. It's the 1-prop z int, 1-prop z int. So just so we're clear, I went the stat button. I scrolled over to tests. I'll get there. I don't know what it is off. And the 1-prop z int. That sounds about right, Danielle. But let me just plug it in and see. So 1 dash prop z int. So that's why I found x, because you needed it for your calculator here. So it's 160. There were 500 people. And that's it. Yep. You're welcome. You're welcome. And then I think there was a, did you say you also had a question? Did somebody? So you are more, I allowed the, I just allowed a second submission on the homework. So you can go back and resubmit the homework, Emmanuel, and I'll just disregard your first submission. Sound good? You can round to whatever you want.
Professor, when will we have the final exam? What do you call it?
Our last exam number 4, is going to be next Thursday, the 17th. Yeah.
Okay, and we're having a review this Thursday and next Monday?
No, so today what I'm going to do is I'm going to do hypothesis testing for a mean. Thursday, I'm going to do a new thing called hypothesis testing for a proportion. And then I'm going to review on Tuesday, the 15th.
Okay.
And then, yep, I'll spend all 2 hours reviewing for you. And then we'll take the exam on the 17th.
Okay, sounds good. Thank you.
Yep. Okay, so Pamela, was it just this first one, find a point estimate?
Hi, I just realized in yours, this has 3 questions, but in mine, it only has 2 questions for number 5.
1, 2, 3. There's 3 questions here.
Oh, wow. I don't know.
In mine, it also has 3 questions.
Yeah,
Really?
it should have 3 questions. Just check, re-download it again. There's definitely 3 questions there.
Okay, I will. Thank you. But it's the first part of the 5. I was
Yep.
going over.
So obtain a point estimate. So it goes like this. Number 5 says a random sample of 1,000 Americans. It was discovered that 920 of them lived in neighborhoods with acceptable levels of carbon monoxide. Okay. First part says obtain a point estimate for the proportion of Americans who live in neighborhoods with acceptable levels of carbon monoxide. So a point estimate for a proportion is just p hat. So all you really have to do for this one is you take x divided by n. There were 920 people who lived in neighborhoods with acceptable levels of carbon monoxide. You divide by 1,000, and that's the answer. It was just, yeah, I understand like maybe the vocabulary was a little, like we you know, if you had forgotten what a point estimate was, things like that. Is that, no worries, no worries. That's why I take questions. Yeah. All right, everybody else, I hope you've started the homework. But hopefully you used your calculator quite a bit on the homework, and you know, if you have any other questions, I'm available for 2 hours after class today if people want to get started on it, and then ask me any questions like that. All right, so any other last minute questions on the homework? No questions? Okay. Just remember, if you used your calculator to answer any of these, just make sure you reference, you know, what options you used in the calculator. Like for example, question 1, you should have used stat, tests, z interval for question 1 here. So just make sure that you let me know that, okay, that, hey, I used the option z interval and this is what my answer was. Like for question 2, you actually should have used option number 8, t interval. Okay, and you should have just let me know that in your homework.
So if I already submitted the assignment, but I didn't do that, should I resubmit it?
I would appreciate it.
Okay, no problem.
Just because I'm not saying you made an error, but if you made an error in your confidence interval and you don't show me any work, I just take off full credit. So if you show me work, I'm not saying that you made an error. I haven't even looked at them yet, but just in case.
Okay.
Bum, 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 da, 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 da. All right. Any other homework questions? No homework questions? Closing the book on the homework. Okay. All right. So this is where we were, what we were talking about. Sorry, I know that was a big yawn. I think I do this all the time before this class. I just had my lunch, so I'm always a little tired for this class. It's a foolish mistake, but it's the only free time I have. I think if you look back in your notes from last class, even just look at the recording, we were talking about hypothesis testing for a mean. And I talked about something called the p-value approach. Does that ring a bell? A little bit? Okay. And then what I did was I showed you how to calculate this thing called the p-value by hand. Do you remember that? And then I said, oh, there's an easier way. And I showed you how to use your calculator for this. All right, well, we're going to be doing that a bunch today. We're not going to do anything by hand. We're just going to stick right to the calculator and make it easy for us, okay? So if you don't have it out already, just have handy your TI-83 or TI-84. It doesn't matter which calculator you use, all right? The options look exactly the same. So I'm just going to use the TI-84 here, but again, the TI-83 looks exactly the same. Okay, so this is hypothesis testing for a mean, okay, when sigma, the population standard deviation, is known. Okay, so I just want to do a quick review, all right? In statistics, the p-value is the probability of obtaining results as extreme as the observed result of the statistical hypothesis, assuming the null hypothesis is correct, okay? And what we do is we use this p-value to determine if we either one, reject the null hypothesis, so we can reject the null hypothesis, or what else could we do? What was it called? You could reject, or you could do what?
Fail to reject.
Yep, or we can fail to reject. Okay, those are the two things we're going to be doing. And I think if you guys remember, I walked you through a 5-step process for this. Does that ring a bell too? Okay, and don't worry, we're going to review all of it today. Okay. All right, so how are we going to use the p-value? So what you're going to do is you're going to compare the p-value of the test, okay? And this p-value, all right, we're going to find using the graphing calculator. So we're going to make it easy, okay? All right, with what we call the test level of significance. And does anybody remember what Greek letter I'd use to denote the level of significance? Yep, thank you. So it goes like this. If the p-value is less than the level of significance, you reject the null hypothesis. If the p-value is greater than the level of significance, you fail to reject the null hypothesis. Okay, so if your p-value is less than alpha, you're going to reject. And then here, if your p-value is greater than alpha, you're going to fail to reject. All right, so I have this silly saying that kind of like helps me remember it. All right. When the p-value is low, the null must go. So that's like saying when the p-value here is low, less than alpha over here, the null must go. It's got to be rejected. And when the p-value is high, so the p-value is above alpha, all right, the null must fly. What that means is the null's good. You fail to reject. So it's a kind of a snappy saying, okay? I hope that'll, thank you for the laugh. I actually didn't make that saying up, by the way. Okay, I wish I could take credit for it because it's kind of an amazing saying, but I did not make it up. I hope it helps you kind of just remember, okay, when to reject or when to fail to reject. But we're literally going to do 5 examples of stuff today. So hopefully by the end, it makes sense for you, okay? All right, so this was the 5-step process, okay, for hypothesis testing a mean, and this is the p-value approach. All right, so I'm going to go through just real quickly the 5 steps again, just so we have them in our mind, because it's all we're going to be doing this entire week. So you're going to define the parameter. So it's going to be something like this. You're going to let mu equal, and then you're going to literally write out like what it is you're investigating. The mean number of blah, 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 whatever it is, okay? And then the next thing you're going to do is you're going to set up the test, okay? How many different test options do we have? Does anybody remember what they were called? There was a right-tailed test, and what were the other 2 called?
Left tail and two tail?
Yep. And what I said was, look, there's going to be like keywords in the problem that tell you if it's right-tailed, left-tailed, two-tailed. But right-tailed tests look like this. It's going to be mu is equal to a number, and your alternative hypothesis is, wait a second, no way. The average is greater than that number. Okay. Left-tailed test, I think we did one example of a left-tailed test last time. It was mu equal to a number, and we're saying, wait a second, no way. No way, the average is less than that number. In two-tailed test, we're saying mu is equal to a number, and what we're looking to investigate is no way, it's changed. It's not equal to that number. It's a different number now. Okay. Next thing you're going to do is you're going to select your level of significance. This is alpha. Okay, and this will always be given to you. And there's 3 common alphas. You could do 0.01, 0.05, and 0.10. The most common one is this one right here. Okay, so that's the one that'll be defaulted to the most. But you'll see, you know, every once in a while I'll mix it up a little bit. But generally it'll always be 5%. All right, then we compute this thing called the test statistic. This is just a number. It's just a z-score, okay? And there's 4 values here. There's x bar, which is the sample mean. Mu sub 0. That's the hypothesized mean or the assumed mean. Okay, it comes from the null. Sigma is the population standard deviation. And n is the sample size. Okay. So we did this by hand last time, but you know what? I'm going to show you your graphing calculator even does this for you. Okay, the graphing calculator is like the greatest invention for this class. Okay. Then the next thing you're going to do is you're going to find the p-value. All right. Again, the graphing calculator is going to do this. Okay. And then you're just going to make your conclusion in step 5. You're either going to reject or you're going to fail to reject by comparing the p-value to the level of significance. And I know it seems weird, but for me to say this, but for as long as I've been doing this stuff, as long as I've been teaching statistics, the hardest part is step 1. Okay, like setting up the test. Like, what are we even talking about? And then is it a right-tailed, left-tailed, or two-tailed test? Once you get that figured out, the rest of it's just like a calculator and then comparing 2 numbers. Okay, so it's actually not really that bad. So we're going to spend time on this part because this is the hardest part. Okay. Everybody okay if I move on? Everybody good? I got 1 yes. Okay. Thanks, Tora. You ever doodle do? That's probably the most enthusiastic I've seen this semester. Okay. All right, so this is the options we're going to do in our graphing calculator for this. Okay. So for the next 2 problems, it's going to be, you're going to load up stat on your calculator right here. You're going to scroll over to tests, and it's going to be option number 1. Okay. So this is important. When sigma is given, okay, so when you're given the population standard deviation, you're going to use the z-dash test. Okay. What we're going to talk about during the second half of class, probably after our break, is the t-test here. Okay, which is just a subtle difference, but it's going to end up basically being the same procedure. Okay. Let's get through 2 examples, okay? And I think this is something we can all relate to, okay? This one is about Netflix, okay? Speaking of Netflix, I know there's this show that everyone's been talking about called The Queen's Gambit. Has anybody watched that yet on Netflix?
Yes, it's really good.
Yeah, it's on my to-do list. I got to do it as soon as the semester's over. Everybody
Even
else
if you
has it
like
to-do
don't
too?
like chess, it's really good.
Yeah.
And I am someone that does not really like or know chess. It's the storyline that's really good.
I believe it. I believe it. What's interesting was I read an article about it, and they said that on Amazon, sales of chess sets after Queen's Gambit came up went up by a factor of 4. And then like there was like a 500% increase in the number of downloads of the chess.com app. It was just really crazy, like how popular the show is. So I'm with you. I have no time yet. So
I'm pretty sure that it's sadly not a true story.
I heard it's not a true story either, but
Yeah.
Still, I heard
But
it's a good one.
it's based on people that are real. It just wasn't a woman.
Gotcha. Well, I'm going to definitely watch it. That's on my next list. All right. Anyway, so this is about Netflix. Okay. So a study conducted in 2015 by this technology company, which is now called TiVo. All right. So it's back then it was called Rovi, I think, or however you pronounce that, but now it's called TiVo. Showed that the mean time spent per day browsing the video stream service Netflix for something to watch was 19.3 minutes. Okay. So basically what they're saying is that people spent 19.3 minutes browsing, okay, before they found something to watch, okay? Next, it said, assume that the standard deviation for time spent looking for something to watch on Netflix is 8 minutes. So you're given this. Okay, so you're given that right off the bat. A social scientist is interested to know whether the mean time browsing Netflix has increased. Okay, so that it's gone up. Okay, so right there, that keyword there, what type of test does this tell me it's going to be? Right-tailed, left-tailed, two-tailed? Yep, it's going to be a right-tailed test. So that's great to know, because what that means, just going back real quick, is I'm going to set it up like this. Okay, this is going to be my test. All right, so this is what happens. Suppose the social scientist takes a random sample of 50 people. Okay, so now you're also given that the sample size is 50, and the mean time they spent browsing Netflix was found to be 21.5 minutes. Okay, so you're given X bar. All right, at the 0.05 level of significance, is there evidence to suggest that the mean time spent browsing Netflix has increased from the 2015 level? So now you're also given alpha is equal to 0.05. Okay. Obviously, just like by looking at it, 21.5 minutes is greater than 19.3 minutes, but this was just a sample of 50 people, right? Like, I don't know if I can say for sure that it's increased, but I don't know, like you got to go through the test to see for sure, because maybe I'm wrong. Maybe that 21.5 does provide enough evidence. I'm not so sure. You know, I know personally, I can't speak for anybody else, but I spend a lot of time browsing Netflix before I actually find something to watch. Okay. So you're given this information here. Is everybody ready for me to go to the next slide and go through the 5-step process? Okay. So the first thing I have to do is I have to define the parameter. Okay. And it's let mu equal to something. Okay, so let me go back. Right? What average are we investigating here? What are we looking to see has increased?
Average
But average what?
browse time. Sorry, I accidentally muted myself.
That's
before I
okay. That's okay. Yep. So what we're looking at is we're investigating the average time people spend browsing Netflix. Okay. And this is in the current year, because like we know what it was in 2015, right? So this social scientist thinks that it's gone up, right? So we're going to let mu be the mean time people spend browsing Netflix before picking something to watch. Has anyone ever done this where they hop on Netflix to look for something to watch and spend too much time browsing, and then they realize they're out of time, can't watch anything? Yeah. Yep. The worst is like at night, I usually give myself half an hour of like Netflix time or something. Netflix is okay. Stop it. I mean, it's no Disney Plus, but you know, it's pretty good. And then you browse for 30 minutes and realize, oh, I can't watch anything. Okay. Yes, it is. So I want to test to see if it's increased. So I'm going to say mu is equal to something, and we're saying no way, mu is greater than something. All right. So what number are we looking to see that the average is greater than? This is where it gets tough, right? Well, what was the average? So hold on. What was the average in 2015? Average was 19.3. And what we're looking to do is to see that it's greater than that now. Okay. So we're looking to show evidence that no way, the average is greater than it was in 2015. So what we're going to have to do then for our null hypothesis is start with the assumption that, okay, it's the same. People still spend the exact same amount of time on average. Okay. But we're looking to show evidence then. No way, it's gone up. It's gone up. There's so much stuff on Netflix nowadays. You spend hours looking. Okay. All right. So once you have this set up here, okay, it's actually the rest of the test like literally takes a minute to do, and you'll see. Okay. Step 2, you select the level of significance. Did I give you that here? Yeah, what is, yep. I will always give you the level of significance. So it's 0.05. Okay. Steps 3 and 4. Okay. Compute the test statistic and find the p-value for the test. I have such good news for you. We're just going to immediately go to our calculator now. All right. So everybody take out your TI 83 or TI 84. It doesn't matter. Okay. I like highly encourage you to follow along with me while I do this. Just because, you know, just so you have practice with it. All right, so to have your calculator do this hypothesis test for you, you're going to hit the stat button. You're going to scroll over to tests, and you want option number 1, z-test. Okay. So how many people now see this on their screen? Okay, you might see something a little different like in mu naught and sigma here. Okay, you might actually see numbers there, but at least I want to see input and stats. Those are the most important. Okay. So just so we're clear, the options we did on our calculator here was I pressed the stat button. I went over to tests. And then it was z-test. Okay, it was the first option. So what you're going to do now is you're going to click on this stats button right here. So you're going to scroll over and go to stats because I've given you the summary statistics. Okay, and you should see something like this. You might actually, you know, this 500 in here is from a different class, but you just want to see these options. Now we're going to go through and change them. Okay. So press the down button to where you see mu sub 0. Okay. This is the assumed value from the null hypothesis. Okay, so this is from H0. So I'm going to put in 19.3. I'm going to hit enter. Sigma. Okay, sigma is the population standard deviation. It was 8. X bar was the sample mean. What was that? On average, how long did people spend from the sample? Was it 21.5 minutes? Yep. And then how many people did I talk to? Yep. The next thing here, what you have to do is you have to pick the sign here to represent whatever your hypothesis test was. So I have, it's a greater than, it's a right-tailed. So I'm going to go down to the right-tailed greater than sign here. Okay, and I'm going to hit enter. Next, you're going to scroll down to calculate. Okay, everybody hit enter. How many people see this exact output right here? Okay, is anybody getting an error or anything? Everybody's good? Marcos, you're good, meaning that you're good, right? That you're okay, good. Yep. So this is actually like all the information you need right here. Like your calculator just did all this work for you. This Z, okay, this is this first thing here, Z is equal to 1.9445 or 1.945 when I round to 3 decimal places. That's your test statistic. So my test statistic is 1.945. Okay. The next thing, if you look on your calculator where it says P, this is your P value. So my P value is equal to 0.026 when I round to 3 decimal places. 0.026. Okay. Was it pretty easy for your calculator to do this? Yep. Okay. Good, good. Okay, so now it's the next part. What's my conclusion? Do I reject or fail to reject the null? And how do you know? So you remember my silly saying? If the p-value is low, the null must go. If the p-value is high, the null must fly. Is this p-value less than or greater than the level of significance? Okay, yep, my p-value, which is 0.026, yep, is less than my level of significance. Which is 0.05. So does that mean we reject or fail to reject the null? Yep. We reject the null hypothesis. Okay, well, what that means when we reject, we're saying we do not believe this is true and evidence supports the alternative. Okay. So when we reject the null hypothesis, what we're saying here is evidence suggests that the mean has increased from the 2015 value. Okay, what we're saying also is people are spending more time on average. Browsing Netflix. And really, we should blame Netflix because they just put so much stuff up there that it's a hard time just make a decision. What do you guys think? Not too bad? Would you agree that the hardest part is honestly step one, setting it up? Yeah, like once you set it up, okay, once you like it's a math word problem, right? Like once you figure out what they're asking, okay, and get it set up correctly, it kind of just falls into place. Okay. All right, so let's do another one, right? Because we just want to get practice in with this. Is everybody okay if I go on? Okay. Okay, this is about satisfied workers. So at a large company, okay, just pick whatever large company you want. The attitudes of workers are regularly measured with a standardized test, okay? So basically the company's like trying to look at like their job satisfaction, okay? The scores on the test range from 0 to 100, okay, with higher scores indicating greater satisfaction with their jobs. Okay, so the mean score of all the company's employees was 74, okay? All right, so that's a given value. With the standard deviation sigma of 8, okay? So some time ago, the company adopted a policy of telecommuting. Okay, obviously with COVID going on, right? Like, you know, telecommuting is good. Depending on the company, right? Like I think sometimes with education, you know, obviously we'll all be back in the classroom next September, but anyways. Under the policy, okay, this telecommuting policy, workers could spend 1 day per week working from home. Okay, after the policy has been in place, okay, for some time, a random sample of 80 workers was given the test. Okay, so now you're also given the sample size. To determine whether the mean, the average level of satisfaction had changed since the policy was put into effect. Okay, so they were just going to randomly sample 80 workers and say, okay, now that there's telecommuting, take the satisfaction test again. The new sample mean ended up being 76. So it's gone up a little, okay? Using this sample at the 0.05 level of significance, so I'm also giving you the same level of significance, can we conclude that the mean level of satisfaction is different, okay, is different since the policy change went into effect, okay? Because remember, this is just a sample of 80 people. So from this, can we assume that that the new level of satisfaction, the mean level of satisfaction is different? Okay, so first off, what key word in there tells me what type of test this is going to be? Okay, Melissa, great. What type of test does that imply it's going to be now? Yep, so the word different here tells me it's going to be a two-tailed test. Okay. So like you're good. You've got all the information you need here, okay? You just have to figure out how to set up the test and what to plug into your calculator. And once you do that, it's really not that bad. Okay, is everybody okay if I go on? Okay. I got one yes. Everyone else is like, I've started watching the Queen's Gambit, Matt. Okay. We're going to go through the 5 steps again. Step 1, you're going to define the parameter. It's let mu equal to something. And then we knew that the test is a two-tailed test. So it's going to be mu is equal to a number versus no way mu is not equal to a number. Okay. What parameter are we even investigating here? So I'm going to go back for a second. Okay, what are we investigating? This is where hypothesis testing is a little hard. What is the company interested in investigating? The mean level of what of its workers?
Satisfaction with their jobs.
Okay, and Daniela has it right there. So we're looking at the mean level of satisfaction since the policy was put into effect. So we're going to let mu be the mean level of satisfaction since new policy was put into effect. For some reason, I can't get the Rolling Stones song out of my head now. I can't get no satisfaction. Okay. All right, so thank you for the laugh. Nobody wants to hear me sing, honestly. So I have to say, this is the next hard part. Like, what numbers am I going to put here? Okay, so let me go back. Like, what was the mean score before the policy got put into place? Okay, yep. And what I want to do is I want to see if it's different now. I want to see if it's different from 74. So we're looking to show evidence that the mean is no longer 74, okay? And so we'll start with the assumption that it's unchanged, okay? That it's still 74, okay? But we want to show evidence that no way, we're all telecommuting now, it's different. All right, once you have this set up, it's super straightforward. Level of significance is given. Again, it's alpha is equal to 0.05. Compute the test statistic and find the p-value. Our calculator is going to do for us incredibly easy. Okay, so everybody grab your trusty calculator. So to do this, you're going to hit stat You're going to scroll over to tests. And which option was it again? I forgot. Yep, option number 1, z-test. And what you'll notice here, does everybody still have the data from the previous problem plugged in? Or does the TI-83 erase it? I forgot. It's still plugged in? Yeah, so all you have to do is just go over it. It's not a big deal, okay? So under stats, okay, make sure you have stats selected. You're gonna go down to mu sub 0. You're gonna clear out, and you're just gonna type in the new 74. Was the standard deviation the same? Yeah, oh, for some reason I picked the same standard deviation. Okay, standard deviation is 8. So leave that. The new X bar was 76. That's okay, that's the new satisfaction level. And how many people did they sample at this company? Yep, 80. And then you just want to make sure that you have it selected as a two-tailed test. That's incredibly important, okay, that you have the right alternative selected. So then you're just going to go down to calculate, and you're going to hit enter. All right, how many people see this right here? Okay, we got it? Wow, so it looks like this. My test statistic is 2.236, can't speak. And my p-value is 0.025, 0.025. Okay, so this is from the TI calculator. Can't spell today. Okay, can anybody tell me what the conclusion is? Do we reject or fail to reject this one? Yeah, again, you reject. All right, and this is because the p-value is less than the level of significance. So even though it was a small change, we could still say the mean satisfaction level has changed since the new policy. It won't always be the case that you'll reject, but in this case, we just had two problems where we both rejected the null hypothesis. What do you think? Not too bad? Not too bad, not bad. Again, it's just this, right? This is the hard part, I think. Okay, once you have this set up, once you have this set up, the rest of the test just like, it's just plugging stuff into the calculator. I get it. And that's why we're going to keep doing more problems after the break, just so you can get used to this, like understanding the problem. And then again, this is all we're going to do on Thursday. Okay, more hypothesis testing. Okay, so it's break time. I'm going to take a 10-minute break. Does anybody have any questions before we hit break? All good? Okay. So let's be back at 2 o'clock. At 2 o'clock. All right, I'll see everyone in 10 minutes. Sound okay? Okay, see you in 10 minutes. I just want to look at something real quick. I'll see you guys in 10 minutes. All right. Can everybody hear me okay? We're good? Yeah, everybody's okay? All right. Let's finish up for the afternoon. But before I do, does anybody have any questions about any of that stuff that we talked about for the first hour before I go on? Okay. We're gonna keep relying heavily on our graphing calculator. I think you guys all feel as I do that the graphing calculator really helps make this stuff very manageable. We would just spend more time able to go through more problems and really think about, conducted tests as they would be done in the real world instead of just everything by hand. So what I want to talk about now is hypothesis testing for a mean. This is when sigma, the population standard deviation, is unknown. Okay. So this is how hypothesis testing is actually done in the real world. Can anybody tell me why, looking even back at a problem like this one here, why this isn't what assumption do we make in this problem, or what's given to you that would probably not be given in the real world? Does anybody know? Yeah, thank you. Yeah, in the real world, you're not going to know the population standard deviation. If you notice, I'm just assume the population standard deviation is 8 minutes. Where does that even come from? Why would I make that up? Or how would this, this one here, the population standard deviation is 8. Okay, that's what it was related to the previous test. How are we sure that it's going to be the same for the new test? It just doesn't. Knowing sigma just doesn't happen in the real world. Okay, so this is how, as I was saying, hypothesis testing, how it's done in the real world. Outside of the academic classroom, right? And if you look here, here's the crux of it, okay? To test hypothesis regarding a population mean, assuming the population standard deviation is unknown, we're going to need to use the t distribution. Okay, do you guys remember not a while ago, maybe last week, we were talking about the t distribution, the student's t distribution? We did them for confidence intervals, rather than a z or rather than a normal distribution. And that's because when we replace sigma, all right, in our test statistic, this is a mu with a subscripted 0 should be there. Okay, our test statistic no longer follows a normal distribution. It follows a student's t distribution. Okay. In the grand scheme of things, the process isn't that different. Okay, we're still going to use calculator. Still use the p-value in the calculator. Okay. Just a different test. Okay, so if everyone just grabs their calculator for a quick second. If you go back to stat and then you scroll over to tests, you see how option 1 is called the z-test? What's right under it? What's option number 2? Yeah, that's the only difference here, okay? We're just gonna have to use, instead of a z-test, you're just gonna have to use a t-test. So really, what now becomes difficult when you do these hypothesis tests, not only do you have to set up the test, but now you need to know if you're given S or if you're given sigma, okay? And there's just gonna be dead giveaways for this. When you look back at the previous problems, I literally say something like, assume the standard deviation for time spent watching Netflix is 8 minutes. So I'm like, assume the standard deviation is this. Or I say something like sigma is equal to 8. Like those will be like dead giveaways that it's a z-test. Okay, so I want to show you now what's the subtle difference that it'll be a t-test. All right, but the 5-step process for this, a little bit of a typo here. It's the p-value approach. Okay, this is the same step. Step 2 is the same. Step 5 is the same. Okay. Step 3 and 4 are the only things that are different in this hypothesis test. Okay. And the only reason they're a little different is just because your test statistic is different. Okay. Like before, our test statistic was denoted as z sub 0 and it had a sigma here. Okay. Here we're just replacing a sigma with s. And then our p-value no longer comes from a normal distribution, but from a t distribution. All right, but at the end of the day, our calculator will still solve this for us. Okay. And the p-value is still going to be the same. If the p-value is less than the level of significance, you reject the null. And if the p-value is greater than the level of significance, you fail to reject the null hypothesis. But there is, I don't want to belabor too much time here. Like really, it just comes down to like read the word problem and figure out if it's told to assume the population standard deviation is something, or if you're given a sample standard deviation. Okay. Are you ready for our first example of this? And then I promise you, after you see an example, you're like, okay, yeah, this makes sense. It's not that hard. All right, so I have 3 problems picked out here. I actually want to start with problem number 2. Okay. And then I'll get back and do some of the harder problems, like question number 1. But let's start with number 2. It's a little bit easier. Okay. Okay, so according to the most recent general social survey, and I think I've talked about the general social survey in this class. Okay, it's a survey of opinions and lifestyles of US adults conducted by the National Opinion Research Center, NORC, at the University of Chicago. Okay. And the most recent data I have is actually from 2017. Okay. So the average person watched 238 minutes of TV per day. So that's just a little bit under 4 hours. Okay. What do you guys think of that number? Is it high? Is it low? Yeah, I know. They definitely have nothing to do. Yep, it's high, but it's tough, right? Like, that's the average of everybody, right? Like, obviously students and working adults watch less TV, or maybe not, I don't know. But if, you're retired, I think we've talked about this. If I was retired, I'd be up to date on Queen's Gambit, so I don't know. I don't know about that number. So here's the question. A researcher believes that the mean hours of TV watched by millennials, okay, so by a specific generation, okay, is different from this amount. Okay, so the keyword different tells me this is going to be what type of test? Yep, right there. The keyword tells me it's going to be a two-tailed test. Okay, so this researcher just believes it's different. Okay, so what's going on here is the researcher's not sure if millennials watch more TV or they watch less TV. The researcher, he or she, just wants to see if it's different. Okay. So to test the claim, the researcher samples 51 millennials. Okay, so I'm just writing what you're given. You're given the sample size, 51. And find that they watch 215 minutes on average per day on average with a standard deviation of 115 minutes. Okay, so do you notice that this problem, unlike the previous ones, doesn't say assume the standard deviation is this? Do you notice how it just says, hey, look, I took a sample, and from the sample, the researcher got an average of this and standard deviation of this? Do you notice the subtle difference? And one, yes. Like if you look at all the other, right, if you look at all the other problems that we did, like even if I go back, you're given sigma is equal to 8, or assume the standard deviation is this. Okay, in this type of problem, you're given the sample standard deviation. Okay, so that right there, when you're given S, okay, you're going to need to use the t-test right there. That's the dead giveaway. Okay. And then it says at the 0.01 level of significance, so you're given alpha. All right. Is there evidence to suggest, sorry, a little bit of a typo there, that millennials do not watch TV at the same level on average as the average person in 2017? Okay. All right, to conduct these tests, all right, you need these three things. You need N, X bar, and S. All right, then I'm going to give you the level of significance, and then by extension, you're going to be given some other number that's going to help you set up the test. Okay. Is everybody ready for me to go on? Stop watching Queen's Gambit. All right, so I'll go on here. I'm going to go through the 5 steps for this, okay? All right. It's actually example number 2. And it's the p-value approach. Sorry about all the typos here. Okay, so we're going to define the parameter. Okay, so we're talking about a mean of some type, and we said it was next, and then we said it was a two-tailed test. So a two-tailed test is mu is equal to something versus mu is not equal to something. All right. So what average are we investigating here? The average what? I think it's about average minutes of TV watched per day by who? Got to be very specific here. So there's 3 things: person watching TV, millennials, or adults, right? So like the researcher believes, the researcher believes that the mean is different for millennials. Okay, so millennials, okay, for whatever reason, we just are investigating to see if their average hours of TV watched is different. Okay, so we're looking at the mean minutes of TV watched per day by millennials. Okay. And we want to see if their mean hours of TV watched per day is different from what number? Yep, exactly. So I know that for the general population, it's 238 minutes a day. Okay. So I'm going to say millennials, no way, it's different. Okay. It's different from that number. So if we want to find evidence to say that it's different from 238, we actually have to start with the assumption that it is equal to 238. And we want to show evidence that, hey, wait a second, no way. Okay, millennials are too busy, or I don't know, it's just not that number anymore. It's different. Okay. Step 2. What's my level of significance here? Yep, 0.01. It's going to be right there in the problem. All right, so compute the test statistic. and then compute the p-value. Well, good news. Your calculator is going to do this for you very, very easily. Okay. So grab your trusty calculator. You're going to hit the stat button. You're going to scroll over to tests. And now it's going to be a t-test. It's going to be option number 2. Okay, so everybody click option number 2 on your calculator here. So I'm going to go back and just write that down for us. It was stat, button, then you went over to tests, and then we're doing a t-test. Okay, so again, what I do is I give you the summary statistics. So scroll over to stats and hit enter. And then it's just like the same thing we did in the first hour of class, okay? So scroll down, mu sub 0, that comes from the null, it's 238. X bar, I'm gonna go back so you can see it, was 215 minutes. Their standard deviation was 115 minutes. And then what was the sample size here? How many people did we talk to? $51. Yep. And then just make sure that the two-tailed is selected right here. And then you're going to go down to calculate. Right here, calculate. And how many people see this right here? Everybody good? Everybody's got this? Okay. All right. So let's go back. So this T right here, this is my test statistic. It's negative 1.428. And my p-value is the next number here, p. So it's p is equal to 0.159. 0.159er. What do we think? What's the next step? Do we reject or fail to reject? And why? Alyssa, you're right. We failed to reject. Can anybody maybe say why? Okay. Yep. Dulesky got it. Yep. Because the p-value is greater than the level of significance. So this is what's going on here. We failed to reject the null. Okay. This is because the p-value, which was 0.159, is greater than the level of significance. Which was 0.01 for this test. So what this means is the evidence that we collected, this sample of 51 millennials, evidence does not suggest the mean minutes of TV watched per day by millennials is different from 238 minutes. Okay, so we can't say, you know what, the researcher, to see if it was different, there was no evidence to suggest it. Okay, so unfortunately, millennials, for whatever reason, just watch as much TV as the rest of us. You can blame Netflix. So what do you think? We've done 2 where we've rejected and 1 where we failed to reject. You know, once you get the test set up correctly, okay, once you get step 1 done, do you guys think it's the rest of it kind of just like falls into place? Yeah. Yep. I agree. All right. How about we do like the hardest problem that I can think of for this? Okay. What do you think? We'll rip it. We'll step it up a notch. How about that? I'm going to throw the hardest problem I can at you, and it's still not going to be that hard. Trust me. Okay. So I want to go back and do problem number 1 here. Okay. And I'm sorry, I didn't mean to go fast. Everybody okay if I go on now? Anybody need this? Everybody's good? Okay. This is as hard as it gets here, this problem right here. And actually, this was a question I asked on last year's final exam. Okay. So, you can see a problem, as literally as hard as it gets. Okay. Everybody's thinking like, why would you put the hardest problem on the final exam? But, I'm going to walk you through, I've walked the class through problems like this before, but anyways. So this one is about acid rain. Okay. So acid rain from the burning of fossil fuels has caused many lakes around the world to become acidic. Okay. So the biology in the lakes often collapses because of rapid and unfavorable changes in the water chemistry. Okay, so a lake is classified as non-acidic. Okay, so it's classified as non-acidic if the pH is greater than 6. Hold on, I'm sorry. I just have to step out for 1 second. I'm so sorry. My wife just gave me a emergency text. Give me 30 seconds, okay? Sorry, everybody. Sorry about that, everybody. Okay, everybody can hear me okay? Turned out I misinterpreted the text. She did not need me right now. But anyways, I thank you very much. The joys of working from home, right? Okay, so first off, this is kind of a hint of this problem. Greater than, so this is a little bit of a preview, but when you see the words greater than, what type of test is this do you think it's gonna imply? Right-tailed, left-tailed, two-tailed. Yep. Okay. Okay. So these two authors, I'm not even going to try to pronounce their last names, measured the pH of high mountain lakes in the Southern Alps. Okay. So they investigated the pH level in high mountain lakes in the Southern Alps. Okay. And reported their findings. Okay. In this paper. Okay. Reconstruction of pH by, I'm not even going to try to pronounce that, scales in some lakes of the Southern Alps, okay? So this is not made up data, okay? Like some of my problems, this is real. And the table below shows the pH levels obtained by researchers, okay? So at the 0.05 level of significance, determine whether the data provided sufficient evidence, okay, to conclude that on average, high mountain lakes in the Southern Alps are non-acidic. Okay, that for whatever reasons, they're not, these lakes in the high mountains of the Southern Alps are not becoming acidic. Okay, that they are non-acidic. Okay, does this one seem like a little bit more challenging than the previous ones? Or maybe, nah, seems okay. A little. So it's a little bit more wordy, right? And like, do you notice the subtle difference here? Like, do I, in every single problem we've done before, have I given you the mean and standard deviation? Or in this problem, did I just give you the raw data? So we did a problem like this before for confidence levels, confidence intervals. We haven't done this specific one before, I don't believe. Okay. All right. So let's just go through it. So notice, just as we're clear here, notice you're given raw data and not the summary stats. Okay, so you're not given X bar and S. Okay, but that's okay. All right. So at the 0.05 level of significance, determine whether the data provides sufficient evidence to conclude on average, high mountain lakes in the Southern Alps are non-acidic, i.e. their pH is greater than 6 on average. All right, let's go through this test together. So again, it's the p-value approach. Step 1, we have to define the parameter. Okay. What is the parameter we're investigating here? This is where it gets tricky. All right, and then going back, we also said it's going to be a right-tailed test, greater than. Okay, so you are right about something. Hold on. So it's mu is equal to something, and mu is greater than something. But like, what is the average mean? What mean are we investigating here? We are going to test to show evidence that the pH level is greater than 6, but the pH level of what? This is where it gets a little confusing. Not of oceans, of lake, okay, but of what lakes? You got to be more specific. High mountain lakes where? Yeah, you have to be so specific, right? Because like this hypothesis test is only saying something about the mean pH level in high mountain lakes in the Southern Alps. So we're going to let mu equal the mean pH level of high mountain lakes in the Southern Alps. Okay. And I wanted to test to see that their pH level was greater than what? Six. Yep. All right. So if we want to test to show evidence that it's greater than 6, let's start with the assumption that the mean is 6. Okay. Because remember, if their pH level is greater than 6, it means there's evidence they are non-acidic. Okay. All right. Now, once you have this set up, it's actually really straightforward. The next thing you're going to do is you're going to select the level of significance. Okay. I give you it. It's 0.05. Now what you want to do, when I give you the raw data, so I'm going to go back. When I give you the raw data, what you want to do is you want to take this data and you want to plug it into your calculator, okay? So everybody grab their calculator and you're going to hit the stat button. So you're going to hit the stat button and under number 1, edit, you want to edit the list, okay? Hopefully what you should see up here is L1, okay? Does anybody not see L1 here? Does anybody have data plugged in here already? Yep. I can start again. Okay. So to plug this raw data in, what you're going to do is you're going to hit stat button. Under edit, you want number 1. You want to edit the list. Okay. Did that help, Paulina? Okay. So if you have numbers here like this, like I'm going to show you exactly how to remove data again. So if you have numbers here, what you want to do is you want to scroll to the top. So L1 is hit highlighted, and you want to hit clear and then enter. Okay. So again, if you have data plugged in, you're going to scroll to the top of the list and you're going to hit clear and then enter. Okay. Everybody got L1 and their data cleared? Okay. Next thing you're going to do is you're just going to start plugging these numbers in. It's you know, it's not hard, it's just time consuming. So, you know, I'm plugging it in column wise. So that's 7.3, 6.3, 6.9, 6.1, 5.5, 6.7, 6.9, 6.3, 7.9, 6.6, 6.5, and then 5.8. So you should have all this data plugged in. Okay, does anybody still need me to leave this up here? Or is everybody good with me? Good. I got one. I'm good. Good. Okay. What's really awesome now is like your calculator will actually even do the hypothesis test for you from just raw data. So everybody hit the stat button again. You're going to scroll over to tests. All right. And when you just have raw data, okay, in this class, you're going to go to option number 2, okay, t-test. And you're going to hit enter. And how many people see the previous data plugged in here on their calculator like this? Okay, that's totally fine. Totally fine that you do. What you're going to do is you're going to scroll over to data and hit enter. And does everybody see this on their screen right here? Okay. So now what you need to do is you need to just scroll down. Mu sub 0. We're no longer testing 238. That was our previous example. We're testing it that the mean is equal to 6. You're going to put 6 in. You're going to hit enter. It's going to say, hey, what list is your data in? Hell, yeah, it's in L1. It's already there. So then you're just going to scroll down and you want to match the alternative greater than in your calculator right here. All right, so then you're going to scroll down to calculate. Calculate, and you're going to hit enter. Now, how many people see this output right here? Okay, does anybody need to see me do it again? It's okay if you do. Yep, no problem. Okay. So you're just going to hit the stat button, scroll over to tests, and it's option number 2, the t-test. And then you wanted to make sure that you had data selected. mu sub 0 comes from the null. So it's that it's equal to 6. You don't want to change the list here. It should say L1. Then you want to change the alternative to match as a greater than sign, greater than. So you just make sure that that's highlighted. And then you scroll down to calculate. And you should see that output right there. Good. Yep, no problem. So if I give you the raw data, it's actually like super easy. You just plug the data in and then your calculator will do the rest for you. Okay. So T, this is my test statistic. It's 3.459 when I round to 3 decimal places, 3.459. Compute the p-value. Well, if you go back to your calculator, p is equal to 0.0019, so 0.002. All right, so what's our conclusion here? Why do we reject the null? You're absolutely right. Because what is less than 1? Yep, we reject the null. This is because our p-value is less than the level of significance. So what that means is that evidence suggests that the mean pH level in high mountain lakes in the Southern Alps is greater than 6. Okay, meaning another way that on average, the lakes are non-acidic. Which is good. So again, really, like I think the hard part here was like just setting up the test, and then your calculator just goes right through it. Not too bad. Yeah. We'll get more practice with this on Thursday, but I'm going to end class about 10 minutes early today. I hope that's okay with everybody. And we'll do the next example at the start of class next time to as a refresher for us. Sound good? Mm-hmm. All right, everybody, I'm going to stop the recording.